Good day everyone. Today we are going to talk about Airbnb data management with MongoDB and Hadoop tools. Alright, let's get started. I'm sure you heard about Airbnb. Airbnb is a growing fast in providing accommodation service around the world and has developed as an online platform community. And due to the nature of its business, Airbnb has positioned itself as a data-driven company and they are focusing a lot in building the data infrastructure. Here's the problem. Airbnb has massive number of listings from different locations around the world, producing lots of structured and unstructured data such as photos, comments that are updated frequently from time to time. And this creates a problem for public users like us who are interested to use this data as commodity hardware machines are unable to fulfill the needs. So we set three objectives here. First is to build a data pipeline for managing the Airbnb data. Second is to use the different data access tools such as MongoDB and Hadoop tools for managing Airbnb data. Third is to compare the effectiveness of these tools for performing the process of loading, querying, and also running of analysis. For this project, we are taking data from the Inside Airbnb website, which provides the data sets such as listing, reviews, calendar in compressed files to Airbnb listings for about 108 locations. This diagram shows the overview of the progress flow of our data pipeline. We wrote a shell script to automate the process to download Inside Airbnb data to local file system by taking Singapore data as the demonstration purpose. This process is generalized for other location data, and the data is unzipped before storing into HDFS. Then we use MongoDB and also other Hadoop tools such as PySpark, Hive, and Pig to carry out the data transformation, querying, and also running of analysis.
So I'll take over to talk about the process flow of PySpark. Before we run any data query and analysis, we need to install Python and set up a Python virtual environment on our Ubuntu terminal. And we will also need to install and run the Jupyter Notebook, and it will prompt the Jupyter Notebook in the browser. So after this, we can start to install and import the PySpark library so that we can use the PySpark function. And to load the data from HDFS, we will need to use this Spark read format function with several parameters, of course. And after loading data, you need to do some data preprocessing on each of the dataset listing, reviews, and calendar. After this, we can start to do the data query and even data analysis. And we store the output of the data analysis back to HDFS. And lastly, we will also compute the execution time of each session. I'd like to pass to Brian to talk more about PySpark.
So first of all, because we are only interested with listing IDs that has more than 50 reviews, so we use this line of code to count and also filter the IDs that has more than 50 reviews, and then so that we can perform data query accordingly. As for the analysis of data, for example, we want to find the count by each room type. So first we can use group by function to group the room types, and then use count function to find how many listing IDs contain this specific room type, and then we can sort them accordingly by using descending order, and then we store the output to the HDFS and also calculate the execution time at last. As for the findings and limitations of Spark, we found that this tool is quite easy to be implemented because it can be directly used in the Python environment by just installing the packages inside. Besides, the readability of code, maintenance, and familiarity is much better as compared to the other tools as well. However, for the limitations part, they don't have any file management system, so they have to depend on the other tools to manage their files, such as HDFS. And then the second limitation would be the need to always set up the Python environment before using it. So this would be somehow inconvenient when compared to the other tools, by which they can directly execute their commands in the terminal itself.
I'll explain the process flow of Apache Pig. The first step is loading data from HDFS using CSV Excel storage command. This command facilitates to load the data with multi-line and skip the header. Then pre-processing is carried out. Irrelevant symbols and unwanted characters were replaced with space using replace command. Host identity verified and amenities attributes consist of list of items. These items were tokenized into several tokens. Further, change of data type and extraction of year and month were carried out. Second step is querying data. In this stage, listings with more than 50 reviews were filtered from reviews. Finally, a combined table was generated by joining the two tables by listing ID. Top 20 listings were queried on selected attributes. Next step is analyzing data. For info analysis of room type is shown here. Next, outputs are stored. Finally, execution time for each of above steps were measured. These are the findings and limitations of Apache Pig. It's effective for handling unstructured and messy large datasets, easy programming. It is procedural in nature, so easy to control execution of every step. Limitations are lengthy codes. Commands are not executed until dump or store the results.
Moving next, Apache Hive. Due to some challenges of Hive in pre-processing the unstructured data, there's the clean dataset from Pig will be used and continue with some of the steps to ensure the data flow into Hive environment. One key difference would be the inclusion of data storing step in the script of Pig, where the clean dataset from Pig will be now stored at the HDFS. This applies to all the three datasets, namely listings, reviews, and calendar. Firstly, database called BDM3 will be created. Then schema for each attribute will be created, and this applies to all the three datasets. Then the clean dataset from Pig could now be called in using the command as shown in the picture below. Same steps apply for reviews and calendar tables. Next, query step. Create view was used to ensure the outputs obtained could be saved and could be also called back in the later steps. The final view from this step would be used in the following queries. Lastly, analysis step. There was a total of 6 analysis steps, like number of listings were computed according to different room types, property types, and so on. Moreover, there were some good findings here. It was simple and easy to run the command as Hive was an SQL-like query language. It would be easier for someone who had basic knowledge in using SQL to learn and pick up Hive too. Also, the execution time was not too long and the command line was simple and short. Nevertheless, the first limitation was the difficulties to transform unstructured data to structured data using Hive 2. This was indicated by researcher Liu, where it was challenging and harder to conduct updates using Hive 2, and also the number of statements needed will be higher. Second, to save the outputs from one query in order to be used in another step, create view will be needed in order to keep the process data. Thus, this led to an increase in the command needed as the outputs from one step will not be continued to the next step automatically.
Besides Hadoop tools, we also use MongoDB to solve Airbnb problem. There are two ways to work with MongoDB. One is to use the shell command, or we can use GUI tools. And we have chosen to use the Mongo Compass to solve our problem. The advantages of MongoDB, it is schemaless, high speed, high availability, and horizontally scalable database. However, there are also limitations like can't join the tables or long scripting if we are not using the GUI. A bit of twisting on the process is required for MongoDB due to the different characteristics as compared Hadoop tools. We create the collections by importing the CSV file directly instead of HDFS, and we define the data type. We use aggregation pipeline framework for query and data analysis. There is a list of operators available that we use to query the data like project, lookup, unwin, trim. The pipeline can be saved as view and it can be viewed as JSON format or tabular format. The view result can be easily exported to CSV file by using the out-of-the-box function. There is also an out-of-the-box features available to evaluate the performance of the query.
This is the MongoDB pipeline of querying data. Compared to other, MongoDB cannot join the table directly, and the second table will be stored as array, so we need to use the unwin to deconstruct it and create separate output document for each item. This is the query result view. These are the views of top 20 listing: internal accuracy, check-in, cleanliness, communication, location, overall, and values. This is a MongoDB process of data analysis. This is the analysis result view. This is the evaluation result. We don't have the result for load data from HDFS because we load data directly by uploading the file.
Here comes the results. Comparing among machines, those with higher ranks and costs had faster computation time. Comparing among tools, Pig is the fastest during data loading as schema was not required to be assigned. But it was still the slowest as commands are not executed until it reaches dump. Next, within the Hadoop tools, PySpark is the fastest to query and analyze data as its parallel execution utilizes all cores. Also, Hive is faster than Pig as it consumes less memory with the create view function. Though we can't deny that MongoDB Compass was the fastest to perform data analysis, but it cannot be compared with PySpark because it uses GUI. Moving on, for programming complexity, PySpark and Hive wins hands down with its simplicity, while Pig has lengthy codes. For MongoDB Compass, it is easy, but not with Ubuntu that has even longer scripting. Next, PySpark only has the visualization ability, and for data transformation, Hive is the hardest to execute, which explained the slowest loading time earlier. Hence, we achieve our objectives by building a data pipeline for Singapore Airbnb, but do note that it is flexible to accommodate other locations. Also, we managed to utilize MongoDB and other data access tools for Hadoop while we evaluate their efficiency. So PySpark was the best due to its fastest processing time, yet simple. It can be extended to perform machine learning and visualization. Speaking of that, machine learning and visualization extension to the pipeline process can be one of our future works. Also, it will be best to include security features like Apache Knox. So that's all from the group. Thank you.